Hello, welcome to my YouTube channel. Today we will discuss chemistry paper that were in Monday 11 January 2021. Unit 4CH1 Science Double Award for SDO Paper 1C. Before starting solving this paper, please like this video and subscribe to my YouTube channel. Okay, start. Okay, the first question. This question is about states of matter. Use the words solid, liquid, or gas to give the initial and final state of matter for each of the changes listed in the table. The first one has been done for you. Okay, the melting, initial state will be solid and liquid. Okay, and the next one, sublimation. In sublimation, we know that initial state of matter will be solid and the final state will be gas. And condensing is being gas into liquid, like converting gas into liquid. And evaporation is evaporating like the changing of state liquid to the gas. Okay, the B part. Particles in a solid are closely packed, arranged in a regular pattern and vibrate about fixed positions. Describe the arrangement of and the movement of the particles in a gas. Okay, in the gas state, the particles are randomly they are in random arrangement. In random arrangement, and there is large gaps between them. They move randomly and move very quickly because of high space. The second question. The table gives the melting and boiling points of four pure substances: W, X, Y, and Z. Melting point in Celsius, boiling point in Celsius. Okay, use data from the table to answer the questions. Which substance is a gas at 100 Celsius? It means that its boiling point should be below 100, or it should be about 100 Celsius, and the answer for this question is A, W, because it has boiling point around 660 Celsius. Okay, the next one. Which substance is a liquid for the largest range of temperature? Okay, it means that we should find the differences between boiling and melting point, and the highest difference will be answer for this question. Okay, as we can see, the highest difference is in X, 2500 minus 660 equals to 1840. That's why it's the question. It's the answer for this question. Which substance is a liquid at 1000 Celsius and a gas at 2000 Celsius? Okay. Liquid at 1000 Celsius and gas at 2000 Celsius. Okay. It will be Y, because it will be in a gas form after 1330 degrees, and it will be in liquid form around 1000 Celsius. That's why the answer will be C. Substance Y doesn't conduct electricity when solid, but does conduct electricity when molten. Give the type of bonding in substance Y. It will be ionic bonding. Okay, suggest how the melting point of the pure substance changes when an impurity is added. Okay, the impure substance will melt over a range of temperatures. The third question, lead nitrate and potassium iodide react to form the insoluble solid lead iodide. Crystals of lead nitrate and potassium iodide are placed at opposite ends of a container of water. Solid lead iodide forms after several minutes. The diagram shows the container at the start and after several minutes. Okay, we can see the at the start, the position of the start, and after several minutes. Name the two processes that occur before the solid lead iodide forms. Okay, dissolving happens with it and diffusion, like the potassium iodide and lead nitrate crystals will dissolve and their particles will diffuse. Explain why solid lead iodide take less time to form when the reaction is repeated using water at higher temperature. Because if the temperature of water increases, the crystals dissolve faster, and it means that the particles move faster and rate of diffusion increases. The formula of lead nitrate is PbNO3 to give the number of different elements in lead nitrate. There is three types of elements like lead, nitrogen and oxygen. The answer is 3. Give the charge on the lead ion in like lead nitrate. Okay, it is like NO3's charge is -1 and 2 NO3 will be -2. That's why the lead's charge is +2. Complete the chemical equation for the reaction between lead nitrate and potassium iodide. Okay, we will put 2 right there because like 2 iodide is there and 2 for here. The fourth question. This question is about rusting. When iron rusts, it reacts with oxygen in the air. A student uses the rusting of iron to find the percentage of oxygen in a sample of air. The diagram shows the apparatus. These are the student's results. Volume of air in the conical flask and connecting tube is 265 cm3. Volume of air in gas syringe at the start 100 cm3. Volume of air in the gas syringe at the end 25 cm3. Calculate the percentage of oxygen in a sample of air using the student's results. Okay, first of all, we should find how much oxygen reacted with iron. For finding this, we will subtract 25 from 100 and the answer is 75. And as we know that there is total 365 cm3 of air in whole syringe and flask. That's why we will divide 75 into 365 to find the the oxygen's oxygen's percentage in the flask, and converting to percentage we will multiply it by 100 and the answer will be 20.5%. Cars are painted to prevent the iron in car bodies from rusting. Explain how painting prevents the iron in car bodies from rusting. we know that paint provides a barrier, and like by coating, and it prevents the oxygen getting into iron. Some car manufacturers use paint containing tiny particles of zinc. Explain how particles of zinc prevent iron in car bodies from rusting even when this paint is stretched. Okay, zinc is more reactive than iron. And zinc will oxidize instead of iron. Fifth question. This question is about the separation of mixtures. The box gives some methods used to separate mixtures: crystallization, filtration, fractional distillation, and simple distillation. Okay, complete the table by giving the correct method from the box for each separation. Each method can be used once, more than once, or not at all. Okay, separation and method. Insoluble solid from liquid, we use filtration to do this. For example, like if there is some sand in the water, we can separate the water from the sand and water's mixture using filtration. Pure water from solution. For this, we can use simple distillation, or it can be also fractional distillation. Okay, liquid from a mixture or of liquids with different boiling points. We will use fractional distillation. For example, taking ethanol from water, for water and ethanol mixture. And the last one, soluble solid from a solution, it is crystallization. A student used chromatography to analyze the composition of purple ink. The diagram shows the student's chromatogram at the end of the experiment. Explain which dyes are contained in the purple ink. Okay, according to the chromatogram, we can easily see that A and B contains pink, a purple color, purple ink, because they are like the same height with the RF value of the purple ink. Okay, the next one. Explain which dye is least soluble in the solvent. Okay, the least soluble will be the ones that is closest to the start line, and it is D. And the reason is because the spot is closest to the start line. Explain a different chromatography experiment is set up. A spot of food coloring is placed on the start line. A food dye is coloring has an RF value of 0.72. The distance between the start line and the solvent front is 120 millimeters. Calculate the distance the food dye moves from the start line. For finding it, we will multiply 120 to the 0.72, and the answer will be 86.4. Sixth question. This question is about salts. When solution of salts are mixed together, precipitates sometimes form. The insoluble salt barium carbonate forms as a precipitate. when solutions of the soluble salts ammonium carbonate and barium chloride react together. When solutions of the soluble salts potassium chloride and magnesium sulfate are mixed, no precipitate forms. Complete the table to show the results of mixing solutions of some soluble salts. Okay. Barium chloride solution, ammonium carbonate solution, precipitate of barium carbonate. Okay, barium chloride solution, magnesium sulfate solution, the precipitate of barium sulfate. Okay, potassium chloride solution, ammonium carbonate solution, there will be no precipitate. There's no precipitate. And calcium chloride solution, ammonium carbonate solution, there will be the precipitate of calcium carbonate. The next one, the B1. A student has 4 unlabeled beakers, each containing a colorless solution of a different salt. The 4 solutions are potassium carbonate, potassium chloride, potassium iodide, sodium chloride. Describe a method to identify each solution. Do not refer to safety in your answer. Okay. The first one, doing flame test. Doing flame test for sodium chloride, and it should produce yellow flame because of sodium ions. And the next one, for finding potassium carbonate, should add acid and potassium carbonate, like should produce bubbles because of what? Carbon dioxide. And add silver nitrate solution to find the potassium chloride, and while like if you add the potassium silver nitrate solution for potassium chloride, it gives white precipitate because of chlorine ions. And it's all. The left one will be potassium iodide. Or for finding it, you can add dilute nitric acid, and it gives yellow precipitate if it is potassium iodide. And that's all. The 7th question. This question is about lithium oxide. This diagram shows the electron configurations of an atom of lithium and an atom of oxygen. Describe the changes in electronic configuration when the lithium and oxygen react to form lithium oxide Li2O. Okay, two lithium atoms each lose 1 electron, and oxygen gains 2 electrons. Lithium ion has an electron configuration of 2, and oxide ion is 2,8. The B1. Lithium oxide reacts with water to form lithium hydroxide as the only product. A scientist used this apparatus to measure the temperature change of the reaction. This is a scientist's method. Pour 100 gram of water into polystyrene cup. Record the temperature of water. Add lithium oxide and stir the mixture. Record the maximum temperature reached. The diagram shows the thermometer readings before and after adding the lithium oxide. Complete the table, giving all the values to the nearest 0.1 Celsius. Okay, temperature in after adding the lithium oxide. It is around 27.30, no, 23, no, 27.7. And temperature rise, it will be 20.4. Calculate the heat energy change in the reaction. Give your answer to two significant figures. Okay, like for finding it, we will use the formula of Q equals to mc delta T. Delta T is equal to 20.4 multiplied by the specific heat capacity of water 4.2 multiplied by the volume of the mass of water 100 grams, and the answer will be 4,368 joules, and we should write it in the two significant figure, that's why it will be 4,400. In another experiment, the scientist obtains these results: amount of lithium oxide in mole 0.0580, heat energy change in joules 5,210. Calculate the molar enthalpy change in kilojoule per mole. Include the sign in your answer. Okay, for finding it, we will divide 5,210 into 0.0580, and the answer will be 89,800 joules, which is around 89.8 kilojoule per mole, and this reaction is exothermic. That's why we will put minus sign, negative sign, before 89.8 kilojoule per mole. The next one: give a reason why the scientist does the experiment in a polystyrene cup. Because polystyrene cup is a good insulator and it prevents heat going out. Eighth question. This question is about the halogens. The tables give some information about the halogens. Complete the table by predicting the physical state of astatine at room temperature and color of astatine. Okay, the color, this physical state is it's solid, and color is like black. B1. Bromine has two isotopes with mass numbers 79 and 81. The relative percentages of each isotope in a sample of bromine are: bromine 79 is 51%, bromine 81 is 49%. Calculate the relative atomic mass of this sample of bromine. Give your answer to one decimal place. Okay, for finding this, we multiply 79 into 51 plus 81 multiplied by 49, and we will divide all to the 100, and the answer will be 80, around 80. .0. Give a reason why both isotopes of bromine have the same chemical properties. Because they have same electronic configuration. Okay, C1. A student investigates the reactivity of some halogens. She uses these solutions of halogens and their halides: bromine, chlorine, and iodine, sodium bromide, sodium chloride, and sodium iodide. She adds each halogen solution to each halide solution. The table shows her results. Explain how these results show the order of reactivity of bromine, chlorine, and iodine. the order of reactivity is chlorine most reactive, and bromine and iodine is least reactive. And we should give reason why chlorine the most reactive and bromine is less bromine and iodine is less reactive, because chlorine displaces both iodine and bromine is less reactive because it only displaces iodine. Okay. Suggest why the student does not need to add bromine solution to sodium bromide solution. Because bromine cannot displace itself. The ionic equation for the reaction between bromine and sodium iodide is like this. Explain why this is a redox reaction. Because bromine is reduced and iodine is oxidized. As bromine gains electrons and iodine loses electrons. Okay. Nice question. Propane is a hydrocarbon with the formula C, carbon 3, hydrogen 8. State why propane is a hydrocarbon. Because propane contains hydrogen and carbon atoms only. Name the poisonous gas that forms when propane is burned in a limited supply of air. Means that there is less air, that's why there will be produced carbon monoxide. Say why this gas is poisonous to humans. Because it decreases the capacity of the blood to transport oxygen. The C1. The diagram represents a molecule of propane. Describe the force of attraction between the atoms in a molecule of propane. Okay, there is strong electrostatic attraction between bonding pair of electrons and nuclei, electrons and nuclei of both atoms. Propane can be produced by cracking. An equation for cracking is like that. Explain why cracking is an important process in the oil industry. Because crude oil produces more long chain. Crude oil produces more long chain hydrocarbons than can be used directly, and shorter chain alkanes are more flammable and can be used for polymerization. E1. Propane reacts with bromine in the presence of ultraviolet radiation. Complete the equation for this reaction. There will produce C3H7Br plus HBr, hydrogen bromide. Give the name of this type of reaction. There will be substitution reaction. Substitution. 10th question. This question is about alkanes. The graph shows the boiling points of several unbranched alkanes. Draw a curve of best fit. Okay. Sorry for drawing before drawing. And the next one. Use the graph to find the boiling point of alkane with 7 carbon atoms in its molecule. Show on the graph how you obtain your result. Okay. We'll go from here and there. It is 100 Celsius. Explain the trend shown by the graph. Okay. The boiling point increases as the number of carbon atoms in molecule increases, and the reason is like the intermolecular forces of attraction get stronger and therefore take more energy to break down. The diagram represents two isomers with the formula C5H12. Explain why these compounds are isomers. Because they have same molecular formula but have different displayed formula. An alkene contains 82.8% carbon and 17.2% hydrogen by mass. Show by calculation that empirical formula of this alkene is C2H5. Okay, 82.5 divided by 12 is equals to 6.9, and 70.2 divided by 1 is equals to 70.2, and in ratio it will be like 2 to 5 ratio, and it will be C2H5. Deduce the molecular formula of this alkene. The molecular formula of this alkene is C4H10. D1. The equation for the complete combustion of one molecule of mole of alkene can be represented by this equation. Complete combustion of one mole of alkene produced 308 grams of carbon dioxide and 144 grams of water. X, Y, and Z are the numbers used to balance the equation. Calculate the values of X, Y, and Z. Okay. For finding X, we should divide 308 into 44. The answer will be 7, and X equals to 7. And then for the next one, finding the Y, we will divide the 144 into 18, and the answer will be 8. And for the last one, for finding Z, we should balance the number, and it will be 11. Or we can find it in another way. There is O2 like 32 grams per mole. We can find 32 multiplied by 7 plus there will be 16 grams of 16 grams per mole of oxygen in water, and we'll multiply 16 by 8 and divide all of them into 32. The answer will be 11. And I think the last question, 11th question, this question is about reactions that form gases. Hydrogen peroxide decomposed to form water and oxygen. The equation for the reaction is like that. 25 centimeter cube of hydrogen peroxide solution are poured into a conical flask, and 1 gram of solid manganese 4 oxide is added. Bubble of oxygen gas are formed. Give the test for oxygen gas. It will be glowing splint relights. And the next one, describe a method to show that solid manganese 4 oxide is a catalyst in this reaction and not a reactant. Because like filter out manganese 4 oxide and leave to dry, and same mass of manganese 4 oxide will be there, because it didn't affect the mass of the product or the reactant. Okay, DB1. A student used this apparatus to investigate the rate of reaction between zinc and the excess of dilute hydrochloric acid. This is student's method. Pour 50 centimeter cube of dilute hydrochloric acid into a flask. Add about 1.2 gram of zinc lumps. Record the volume of hydrogen gas collected every 30 seconds until no more hydrogen is collected. The graph shows the student's results. Calculate the mean average rate of reaction in centimeter cube in the first 120 seconds. Like it produces around 280. For finding it, 280 divided by 120, and the answer will be 2.33. The equation for the reaction between zinc and hydrochloric acid is like this. Use this equation and the particle collision theory to explain why the rate of reaction is greatest at the start of the reaction. Because the concentration of hydrochloric acid is greatest, and therefore there are more collisions per unit time at the starting position. It's per unit time at the starting of the reaction. The student repeats the experiment at a higher temperature but keeps all other conditions the same. On the great Drava curve, you would expect to see this experiment. Like experiment at a higher temperature. Okay, if it is higher temperature, the reaction will be faster. Oh yeah, but make sure that it stops in 410, because the rate of reaction do not affect for the volume of hydrogen production. Explain why the rate of reaction is greater if the same mass of zinc powder is used instead of zinc powder is used instead of zinc lumps. All other conditions are kept the same, because the zinc powder have greater surface area and more collisions per unit time. In another experiment, the students add 0.55 grams of zinc to a solution containing 2.5 multiplied by 10 power of minus 2 moles of hydrochloric acid. Use the equation to show that hydrochloric acid is in excess. Okay. First, we should find the moles of the zinc. 0.55 divided by 65, and it is 8.5 46 multiplied by 10 power of minus 3, and we will divide 2.5 multiplied by 10 power of minus 2 into 2, and it will be, okay, I should calculate it now. 2.5 multiplied by 10 power of minus 2 divided by 2. The answer will be 0.125 multiplied by 10 power of minus 3. And we can easily see that hydrochloric one minute. The answer is 0.0125, which is equals to 12.5 multiplied by 10 power of minus 3, and it is much more than zinc. That's why it means that the hydrochloric acid will be in excess. And I think it's the end of the paper. Thank you for attention. As I said, please like this video and subscribe to my YouTube channel. Bye. See you later in my next videos.